how to run a two-sample hypothesis test for independent means. So our example here is a healthcare researcher wants to compare the effectiveness of two different types of pain relief medication, A and B. They select two random samples of patients who suffer from chronic pain and assign one group to take medication A and the other to take B. After 2 weeks of treatment, the researcher measures the pain levels of both groups using a standardized pain scale. The results are as follows. Group A has a mean pain score of 7.5, standard deviation of 1.2 in that sample of 30, and Group B has a mean pain score of 6.8, standard deviation of 1.4, and a sample size of 35. The researcher wants to know if there's a significant difference between the mean pain scores of the two groups. So we can see we were looking for a significant difference, and it's for the mean scores of two groups. So the two groups tells us we have two samples. The mean tells us we're going to be using a t-test, and we're going to be looking for a significant difference. So when we have our null here, we know we have two different means. So we're going to say the first mean equals the second mean. So the first mean score is the same as the second mean score. And what we're looking for if there's a difference. So we want to see if there's a difference between the two mean scores. And then the first one is just going to be our medication A. And our second mean will be from medication B. So now that we know what our hypothesis is, we need to check the conditions, and it's for a two-sample t-test. So the first one we need to know, are the two samples independent? That means we have two different groups of people, and that is true because it told us we have one group is taking the first medication, another group's taking the second, so they are independent. Next, is it random? It told us they were random samples, so we're good there. And the last condition, greater than 30, we're both good here. So we pass our conditions, so we can go ahead and run the test. So to do that, we're going to go into the compare to population means in the DCMP tools. And we want to keep it on the first one up at top. And under enter data, you want to go into summary statistics because we have a summary. If you had a list of data, then you would go into provide your own, but this time we have the summary stats right here for us. So let's name our variable. We're talking about mean pain scores. So let's put our pain scores. Our group 1 is for medication A, and our group 2 is for medication B. So medication A, let's go ahead and put those. So group A, we had a sample size of 30, a mean of 7.5, the sample mean, sample standard deviation of 1.2. Sample size for the second one was 35. Our sample mean was 6.8. And our sample standard deviation is 1.4. So we want to see if the 7.5 and 6.8, if they're different enough. So let's see what we got. We have our test is set up. We need to pick significance test in order for it to do a hypothesis test. So you can see we end up with our test statistic is 2.171. You can see that this lines up with what we have here, our equals and not equals. And we get a p-value of 0.0337. 0.0337 is less than 0.05. So when p is less than alpha, we reject the null. So we reject the null. And when we reject the null, that means we have evidence for the alternative. So we've rejected this. We're saying they're not equal. That means we have evidence that there's a difference. So we have convincing evidence that there is a difference in mean pain scores between the group given medication A and the group given medication B. So this does tell us we have evidence that the first medication was better, was worse than the second one because the mean pain score went down for that second medication. Now, if we wanted to see the confidence interval, we would just change this to confidence interval. And we can see we are 95% confident that the difference in pain scores is between 0.05 to 1.3. So 0 is not in this interval, so there is evidence that the samples are different. And that is how you do a two-sample t-test using the data analysis tools.